For generations, astronomers dreamed of building a telescope powerful enough to look farther into space than ever before. The goal wasn't simply to capture beautiful images, it was to look back in time. Because light takes time to travel, observing extremely distant galaxies allows scientists to see the universe as it existed billions of years ago. To achieve that mission, NASA and its international partners built the James Webb Space Telescope, the most advanced space observatory ever launched. After years of planning and engineering, Webb unfolded nearly 1.5 million kilometers from Earth and began exploring a universe unlike anything humanity had ever seen. Scientists expected the telescope to improve existing theories about the early universe. Instead, many of its first observations raised entirely new questions. When Webb captured its earliest deep-field images, every tiny section of sky was packed with galaxies. Some were spiral-shaped, others appeared elliptical, while many looked completely unlike galaxies in our local universe. What surprised researchers most wasn't simply how many galaxies Webb discovered, it was how mature some of them appeared. According to current models, the earliest galaxies should have been relatively small, irregular collections of young stars that slowly merged over hundreds of millions of years. Instead, several distant galaxies appeared surprisingly large, bright, and well organized. These observations did not overturn the Big Bang theory. However, they suggested that galaxies may have formed and evolved much faster than scientists had previously estimated. Astronomers are now exploring several possibilities. Perhaps the first generations of stars formed at extraordinary speeds. Maybe galaxies merged more efficiently in the early universe. Or perhaps certain physical processes remain poorly understood. Each new observation helps researchers refine existing models rather than replace them. Another remarkable discovery involves the sheer number of galaxies Webb continues to observe. With every deeper image, the telescope reveals countless additional systems stretching across unimaginable distances. Each galaxy contains billions of stars, and many of those stars likely host planets of their own. The enormous scale of the observable universe becomes more breathtaking with every observation. Although scientists still don't know how common life may be elsewhere, the immense number of planets strengthens the possibility that Earth is not unique. Webb is also revealing structures hidden behind enormous clouds of cosmic dust. Unlike visible light telescopes, its infrared instruments can peer through dusty regions where stars are actively forming. Inside these stellar nurseries, astronomers have observed newborn stars surrounded by disks of gas and dust, the raw material from which future planetary systems emerge. These observations provide an unprecedented opportunity to study how stars and planets develop over time. The telescope has also detected surprisingly massive galaxies that existed far earlier than expected. Rather than disproving cosmology, these discoveries are encouraging scientists to improve simulations describing the evolution of the early universe. History has shown that every major scientific breakthrough begins with unexpected observations. And once again, the universe is reminding us that it still holds countless mysteries waiting to be explored. As scientists continued analyzing the James Webb Space Telescope's growing collection of observations, one conclusion became increasingly clear. Every answer seemed to uncover an even deeper mystery. One of Webb's greatest strengths is its ability to study distant planets orbiting other stars. Rather than taking ordinary photographs, the telescope analyzes tiny amounts of starlight passing through a planet's atmosphere during the transit. By separating that light into its individual wavelengths, scientists can identify gases such as water vapor, carbon dioxide, methane, and other molecules. These measurements do not automatically indicate life. Instead, they help researchers understand how different planetary atmospheres form and evolve. Some rocky worlds appear hotter than expected, while others possess thick atmospheres unlike anything found in our own solar system. Every new observation reminds astronomers that planetary systems can develop in remarkably different ways. Webb has also revealed extraordinary detail inside giant clouds where new stars are being born. Its infrared instruments can penetrate dense curtains of dust that once hid these regions from view. Within these stellar nurseries, astronomers have observed young stars carving cavities into surrounding gas while disks of dust slowly gather into the building blocks of future planets. For the first time, scientists can witness many stages of star and planet formation with incredible clarity. Meanwhile, another mystery continues to challenge researchers. Most of the universe remains invisible. Ordinary matter, including stars, planets, and galaxies, accounts for only a small fraction of the cosmos. The rest is thought to consist of dark matter and dark energy, two phenomena that cannot be observed directly but strongly influence how the universe behaves. Although Webb cannot see dark matter itself, its observations help astronomers map how gravity shapes galaxies and galaxy clusters across cosmic time. These measurements are improving our understanding of how large-scale structures formed after the Big Bang. Each new discovery helps scientists refine existing theories while revealing questions that future missions will investigate. Perhaps the greatest achievement of the James Webb Space Telescope is not that it has rewritten science overnight. Instead, it has provided an extraordinary amount of new evidence that allows researchers to test ideas with far greater precision than ever before. Throughout history, astronomy has advanced in exactly this way. Galileo transformed our understanding of the solar system. Edwin Hubble demonstrated that the universe extends far beyond the Milky Way. Later discoveries revealed that the universe is expanding and introduced evidence for dark matter and dark energy. Now, Webb is continuing that tradition by offering the clearest view yet of the early universe. Its discoveries are inspiring the next generation of telescopes that will look even farther into space and detect objects too faint for current technology. Future observatories may directly image Earth-sized planets around nearby stars, study their atmospheres in greater detail, and search for chemical signatures that could reveal environments capable of supporting life. These missions will build upon the foundation that Webb is creating today. Beyond its scientific achievements, the telescope has become a symbol of human curiosity. Thousands of engineers, scientists, technicians, and researchers worked together for decades to make this mission possible. Their achievement reminds us that exploration is one of humanity's greatest strengths. Every image returned by Webb expands our understanding of the universe. Every observation encourages new questions. And every discovery demonstrates that the cosmos is far richer and more complex than earlier generations imagined. The James Webb Space Telescope has not reached the end of the story. In many ways, it has only opened the first chapter. As new observations continue arriving from the farthest reaches of space, one thing becomes increasingly certain. The universe still holds countless secrets. And humanity has only just begun to uncover them.